Hi, good evening everyone. So now today we'll discuss about the galvanic cell or voltaic cell. In the study class we have discussed about electrochemical cell, sorry, electrolytic cell. We have completely discussed about electrolytic cell. Now the second type of electrochemical cell is nothing but galvanic cell or voltaic cell. So please remember, for these cell delta G is equals to negative. Do you remember what is delta G? As delta G is gives free energy, the energy from the chemical reaction which is available for useful work. Now, so let us define what is galvanic cell or what is voltaic cell. See, a galvanic cell is a electrochemical cell. It is a type of electrochemical cell which converts the chemical energy of a spontaneous redox reaction into electrical energy. So once again I'll repeat, a galvanic cell is an electrochemical cell which converts chemical energy. In a chemical reaction, the chemical energy is released in the form of delta G. The chemical energy is nothing but delta G, gives free energy, is referred as chemical energy of a reaction. So that chemical energy of a spontaneous redox reaction, spontaneous means the reaction which takes place on its own, that energy is converted into electrical energy. Now simply, galvanic cell converts chemical energy of a chemical reaction into electrical energy. So in the previous session we have discussed about electrolytic cell. So that electrolytic cell which converts electrical energy into chemical energy. Now this is opposite of electrolytic cell, the galvanic cell or voltaic cell. So the best example of galvanic cell or voltaic cell is Daniell cell. The earliest example of galvanic cell is our Daniell cell. So now this is the setup for Daniell cell. This is for Daniell cell. About this you have learned a bit about this in your first PUC. Now this is Daniell cell. The Daniell cell is made of these components. We'll explain about this later. So now we'll erase this. Now this setup is Daniell cell. See here, in this setup I have taken two beakers, and in one beaker I have kept a zinc electrode. Zinc electrode means what? A metal zinc strip is dissolved in zinc sulfate ions, means this solution contains which ions? Zn2 plus and SO4 2 minus ions. The solution contains Zn2 plus and SO4 2 minus ions, and here this setup is called as copper electrode. The right side is called as copper electrode. Here this is our copper metal, and this copper metal is dipped in copper sulfate solution, 1 or 1 molar copper sulfate solution. So this solution has ions Cu2 plus and SO4 2 minus ions, Cu2 plus and SO4 2 minus ions, and these two electrodes are externally connected by using a electric wire. This is called as electric wire. These two electrodes are externally connected by a electric wire, and these two electrodes are internally connected by using a salt bridge. So this is called as salt bridge, inverted U-shaped tube. So this is called as salt bridge. This salt bridge contains electrolytic solutions. It contains ionic solution. It is made up of ionic solutions. So this is the setup of Daniell cell. Setup of Daniell cell. And so let us study deep inside this. Let us see deep inside this Daniell cell. See here, this Daniell cell is connected. This zinc electrode is connected with copper electrode by using a external electric wire, external conducting wire, and I have inserted a key. And here there is a provision for key, and here there is a meter. I have represented it as A. A means what? It is a ammeter. What is the work or what is the function of ammeter? Yes, it detects the flow of electric current. In an electrical circuit, if there is an ammeter, the function of ammeter is just to detect electric current in that circuit. So here now this entire circuit is closed circuit. This is closed circuit. So here as soon as key is placed, now this is open. Now this circuit is now in the off position. If I place a key, means what happens? The circuit is switched on. On placing key, what happens? The circuit is switched on. As soon as key is placed, we can observe some deflection in the ammeter. The deflection in the ammeter. So this deflection is nothing but the deflection indicates presence of electric current. Means this indicates flow of electric current in the circuit. So means in this cell what happens? There is a production of electric current by the chemical reactions taking place in these two electrolytic solutions or in these two electrode setups. In these two electrode setups, there forms a electrical energy. According to our definition, what is our definition for galvanic cell? A device or a electrochemical cell which converts chemical energy of a spontaneous reaction into electrical energy. Here the chemical reaction, the chemical energy of this reaction is converted into electrical energy. So this electrical energy is used to run the electrical motors or electrical gadgets. So let us write what is the chemical equation taking place in this electrode and in this electrode setup. So this electrode setup is taken as anode. This left side electrode setup is taken as anode, and another one at the right side is taken as cathode. And you all are aware of this. So what do you mean by anode? Yesterday I have given some definitions of anode and cathode. So here anode is an electrode where oxidation takes place. At anode what happens? Oxidation reaction takes place. So here means at anode oxidation. At anode which electrode is there? Zinc electrode. At anode zinc electrode is there, means zinc is reduced. Zinc is not reduced, it is oxidized. At anode oxidation takes place, not reduction. Oxidation takes place. At cathode reduction takes place. Reduction takes place. At anode zinc is oxidized. Zinc is oxidized. And at cathode what happens? At cathode, the cathode is nothing but it is a copper electrode. So this copper electrode, at cathode reduction reaction takes place. So Cu2 plus ions gains 2 electrons and they will give copper. So the first one is oxidation reaction which is taking place at the anode, and second one is the reduction reaction which is taking place at the cathode. So let us sum up these two chemical equations. Let us add these two chemical equations or chemical reactions. To add chemical reactions, we know that the components which are present on reactant side, they are cancelled with the exactly same components if they are present on the right hand side. Let us see, anything is present, the similar things are present on both the sides. Yes, 2 electrons are here on left side and 2 electrons are there on the right side. These two are cancelled out, and what remains? Zinc plus Cu2 plus, means they are in the aqueous solution form, and here what remains? Zn2 plus Cu. So this is the chemical equation of Daniell cell, and we know about this, the chemical reaction, in our first PUC. Do you remember this? Okay. So this is the chemical equation of Daniell cell. This chemical reaction is taking place in the Daniell cell. Here what happens? Zinc is oxidized at the anode and copper is reduced at the cathode. Zinc is oxidized means what? The zinc electrode is dissolved in the anodic cell, and here the copper is deposited on the copper electrode. So here means as zinc is oxidized, it loses 2 of its electrons. Each zinc atom loses 2 of its electrons. So these electrons come here and these electron makes this electrode as negative, and these electrons move towards the positively charged electrode. So this is the direction of flow of electrons. The electrons move from zinc electrode to copper electrode. Electrons are moving from zinc electrode to copper electrode because the zinc losing its electrons, isn't it? So the lost electrons from the zinc are moving towards copper electrode. These electrons are captured by the Cu2 plus ions and they are reducing at the cathode. So this is the direction of flow of electrons, and we know that in which direction electron flow, in the opposite direction current flows, means the current flow from cathode to anode. That I represent electric current. So the electrons are moving from zinc or anode to cathode. In the opposite direction, the electric current is moving from cathode to anode. So this is the flow of electrons, and the opposite is the direction of flow of electric current. So this is the chemical reaction taking place. This is the chemical reaction taking place in the Daniell cell, and due to this redox reaction, this is actually a redox reaction, and this reaction is a spontaneous reaction. This reaction is said to be a spontaneous chemical reaction. So this spontaneous chemical reaction releases some chemical energy in the form of Gibbs free energy. So because of that reason, for these reactions delta G is negative. So the Gibbs free energy released in this chemical reaction is converted into electrical energy. So because of that reason, they are called as galvanic cell or voltaic cell. So this is the story of galvanic cell or voltaic cell. So let us study the same cell in different angle. To this cell, here, for convention I will write this is the direction of flow of electrons. Electron flow from anode to cathode, and this is the direction of flow of electric current. Electric current flow from cathode to anode. To this I will place external potential. I will add external potential to this circuit. So here for a Daniell cell, the potential difference or electric potential is about 1.10 volt. The electric potential produced by this reaction is around 1.10 volt. And so now I will place the external battery, the external current source here. Now I have placed the external current source to this chemical reaction, Now I am adding external current to this circuit. What happens if added external current or added external potential is, if it is less than 1.10 volt? If the added electric current or added potential is less than 1.10 volt, then what happens? The reaction taking place on its own way. So the electrons move from anode to cathode, from zinc electrode to copper electrode. Electrons will move, and in the opposite direction from cathode to anode the current will flow. If the added external potential becomes equal to 1.10 volt, if the added potential becomes equal to 1.10 volt, means exactly as that of the potential given from this chemical reaction, I am adding exact amount of potential to this circuit. What happens if the added external potential becomes equal to 1.10 volt, then the chemical reaction stops altogether. Here, because at 1.10 volt potential is produced by this chemical reaction, I am also adding external voltage, external potential exactly same as that of that was given by the chemical reaction. Now what happens? That those becomes equal to 0. Now what happens? The chemical reactions at these two cells exactly stops altogether. Now if the external potential, the added external potential becomes greater than 1.10 volt, if the added potential is increased, now what happens? The chemical reaction starts again. What happens? The chemical reaction starts again, but in the opposite direction. The chemical reaction starts, but the chemical reaction starts in the opposite direction. Opposite direction means what? The electron flow from cathode to anode. Now the initially electron will flow from anode to cathode. At this condition, when external potential is greater than the 1.10 volt, now what happens? Electron will move from cathode to anode. Electron will flow from cathode to anode. So if electrons moving from cathode to anode, then what about electric current? In which direction it will move? It will move from anode to cathode. The electric current will move from anode to cathode. See, the chemical reactions are exactly reversed. So now if electrons are moving from cathode to anode or from copper electrode to zinc electrode, means electrons are releasing from the copper, means here this copper electrode behave as anode. The copper electrode behave as anode and the zinc electrode behave as cathode. Because it is giving electron, it is receiving electron, means here the reduction reaction takes place at the zinc electrode and oxidation reaction takes place at the copper electrode. The reduction takes place at the zinc electrode and oxidation takes place at the copper electrode. So this reaction is a non-spontaneous chemical reaction. The oxidation of copper in the presence of zinc is a non-spontaneous chemical reaction. The oxidation of zinc in the presence of copper is spontaneous and the reverse is non-spontaneous. The non-spontaneous chemical reaction is taken place by adding external electric current. So now the entire cell behave as electrolytic cell. Now this setup behave as electrolytic cell. See here, when the external voltage, the added external potential is less than 1.10 volt, the cell behave as galvanic cell or voltaic cell. If external potential becomes equal to 1.10 volt, the chemical reaction stops. We cannot detect any chemical reaction in these two electrodes. Now, if the added external potential is greater than 1.10 volt, the entire chemical reaction, the spontaneous chemical reaction is inversed, the reversed. Means the non-spontaneous chemical reaction takes place in the cell. That non-spontaneous chemical reaction is nothing but the oxidation of copper in the presence of zinc. So this is non-spontaneous. As the cell creates non-spontaneous chemical reaction, now the cell is said to be a electrolytic cell. It is no more a galvanic cell. I hope all of you understand this. Okay, thank you so much for watching.